Hello, and welcome to today's webinar, Accelerate Machine Design. Today's webinar will be recorded, and you'll receive a link to the recorded session within the next 24 hours. All attendees will be in listen-only mode. We'll be having a question and answer session at the end of the presentation. If you have any questions throughout the presentation, please type them in at the queue located on the right side of your screen. Presenting today will be Carl Engler, Ally PLM Solutions Regional Sales Manager, and Ben Weisenberger, Ally PLM Application Engineer. And now I'd like to introduce Carl Engler.
Thank you, Tracy. Hello, everybody. It's a challenging time to be in the industrial machinery industry today. The global market for industrial machinery is on the path of recovery. It's projected to continue to post steady growth, and it's estimated to reach $514 billion by 2015. However, it's an industry under pressure. Why? Industrial machinery manufacturers, like you, face dramatic pressure to improve the speed and efficiency of their product design and engineering. This is so they can reduce delivery time and increase profit margins. During this 30-minute webinar, entitled Accelerate Machine Design, yeah, we got the right one here, we'll show you how some of the best industrial machinery manufacturers are building new capabilities and leveraging technology to thrive in this competitive environment. Hello, I'm Carl Engler, and I'm with Ally PLM Solutions. My company has years of experience helping companies, such as yourselves, design better. I'll be your host, and I thank you for joining us today. Here's a quick look at our agenda for today's webinar. First, we'll review recent industry trends, their implications, and the unique challenges that they place on companies like you. Then, we'll identify key capabilities that the best industrial machinery companies exhibit, capabilities that help turn these challenges into opportunities. We hope that this will be an opportunity for you to assess your organization's current strengths and weaknesses. Finally, we'll provide several success stories showing how companies are using engineering software tools to enable these key capabilities to improve and grow their business. So let's begin with some input cost trends. It should be no surprise that raw materials and energy are getting more expensive. Let's face it, it's difficult to predict the next bump in price. This instability in energy and raw material prices leads to inaccurate forecasting of the cost of your products. The result is a threat to sales margin and business profit. Machinery manufacturers, like you, are being challenged to optimize your design processes in order to minimize costs. I'm sure you'll agree that profit margins in the industrial machinery market seem to be getting smaller. There are 85,000 machine tool builders in the world, including many in-house groups, providing tremendous competition. This competition and the price pressures coming from rapidly growing countries like China are forcing you to operate as lean as possible. Like the picture on the screen, I'm sure you're being squeezed into lowering labor costs at the same time maximizing the runtime of your machines. You face an incredible challenge of improving operating costs to stay competitive and produce reliable machines. And if this was not enough, you need to improve your ROI as well as customer satisfaction. Likewise, there is an increase in regulatory compliance and an increase in customers demanding that machine tool builders make their machines as energy efficient and safe as possible. So there has to be a way to design, model, simulate this efficiency and safety before you commit to building your product. In the previous slide, we mentioned government regulations are influencing equipment design more than ever. Adding to that, rising consumer awareness and attitudes surrounding product safety are increasing litigation risk. Send in the lawyers. What this means is industrial machinery companies like yourselves need to apply strong corporate governance within the design and manufacturing process. This ensures that the equipment you deliver meets all relevant industry standards on energy efficiency, materials used and consumed, and worker safety. No longer is it good enough just to produce average equipment. The game has changed, and the industry is demanding lean, clean, and safe machine design. And finally, changing consumer habits and a growing population demanding more products faster is driving an increased demand for more industrial machinery equipment. Environmental concerns are placing a greater focus on packaging recyclability and energy usage. This increased awareness is driving manufacturers and producers of consumer goods to pass on these requirements to their suppliers, making new design requirements on equipment makers. These trends require equipment manufacturers like you to design customized machines faster. Industrial machinery companies are now demanding a better way to provide visualization of these customized products for sales and marketing, along with estimated energy consumption before the equipment is ever built. Again, no longer is it good enough just to produce average equipment. The game has changed, and the industry is demanding lean, clean, and safe machine design. If you're facing these pressures we talked about and more, you're not alone. To help you see how companies are maximizing market opportunities, let's take a look at an industrial machinery equipment leader. MJC Engineering and Technology out of Huntington Beach, California. MJC designs and manufactures custom-built CNC metal spinning equipment and specialty machinery. Let's take a look at the challenges MJC faced. Like the majority of industrial machinery manufacturers, much of the equipment MJC designs and builds are complex projects that need to be delivered by a certain date. This puts their product design on the critical path for profitability. Specifically, MJC faced the following. They need to make sure they make a profit delivering this complex machinery. They are receiving requirements too complex for their old 2D design system. They need faster concept modeling and drawing creation for early design review. To maintain their global leadership, they were committed to finding a way to turn their challenges into opportunities. They took a hard look at their engineering and design processes and capabilities, analyzing their strengths and weaknesses. Now, we'll return to the MJC story later, but now let's take a step back a bit. Let's look at the entire design to manufacturing process for companies like you in the industrial machinery industry. To be competitive, companies like yourselves must adopt effective and efficient order to manufacture and product development processes. In our work with manufacturers like MJC Engineering, we've identified 12 key areas of capability that drive success. As you look at this framework, what areas could your company improve in? What we commonly see is many companies are pretty good in certain areas, but they want to improve in others. MJC began looking at their current CAD solution, which was 2D AutoCAD. For them, speed of mechanical design was their primary challenge. They determined that In order to reduce design errors, a 3D solution would be the key to speed and profitability. In particular, they were looking for a program that would be easy to use and would allow a gradual move into 3D. This flexibility to move slowly into 3D was important because they had a great deal of legacy AutoCAD data they wanted to continue to use. Mechanical CAD is just one of the supporting engineering software tools that can be used to improve your product development and design capabilities. Every company is different, so what is your area to improve? In MJC's case, they surveyed the tools on the market and selected Solid Edge CAD, a unique 3D design system. For MJC, Solid Edge was not just a great 3D CAD solution, but a complete 3D design and engineering package. Solid Edge gave their company new capabilities and technologies in areas like sheet metal guarding and housing, product visualization for sales and marketing, and alignment of customer needs with engineering. Now, all 12 capabilities shown here are important to MJC, but we're going to dive a bit deeper into 3 that are most important for industrial machinery manufacturers. We'll show why these are especially critical and talk about how to overcome challenges and get better in each area. And we'll use Solid Edge to illustrate some of our points. The 3 key capabilities we will look at today are speed of mechanical design, reducing customized content, and manage customer requirements. So let's keep moving. For many of our customers, creation of a 3D model is great for new business. However, they still need accurate 2D working drawings to manufacture the equipment. This is a common challenge for many companies because they end up using different systems for 3D and 2D. With Solid Edge, this is not a problem because we have an integrated 3D to 2D design system built from the ground up to maximize this capability. This is not the case for all other mainstream CAD programs. We recognize most designers and engineers are under pressure to work faster and more efficiently. With Solid Edge, designers and engineers have a complete system to help them design better. To overcome these challenges, Solid Edge provides a complete and integrated environment to make the design process faster and more efficient. Engineers can produce 3D models, accurate 2D working drawings, and reduce design time, eliminating error before manufacture. Solid Edge helps engineers further accelerate the design by providing fast and easy changes to their existing data with tools like Design Configurator, Intelligent Mirroring, Intelligent Placement, Safety Sensor, Replacement Part, just to name a few. These same tools also help with faster revisions. This means you can deliver sooner, invoice earlier, lower business risk, and generate revenue at a higher margin. This accelerated design lets you gain a competitive advantage. Yes, I know most every 3D CAD company can make this claim of being faster. But what makes Solid Edge unique? Well, what makes Solid Edge unique is an innovation called synchronous technology. Synchronous technology is a patented capability available only to Siemens PLM software. This innovation has dramatically changed the game in product development because no pre-planning is required. Since no pre-planning is required with Solid Edge, the user can design in a history-free environment and accelerate the design process. The user does this by focusing on the design intent, not the design tool, and he does not waste time trying to predict future changes like traditional history-based systems. Full digital prototyping can be achieved inside of Solid Edge. It does this by leveraging a hybrid 2D to 3D design environment. Unlike other 3D CAD systems, Solid Edge offers a common user experience for both 2D and 3D users. As we mentioned before, we can do this because Solid Edge was developed from the beginning to be an integrated 2D to 3D design tool. What this means to you is getting your product to market faster, up to 25%. In the fast-paced world of industrial machine design and manufacturing, winning new business and making a profit on projects can hang in the ability to respond quickly and efficiently to customers' demands. Solid Edge with synchronous technology has a unique capability to allow designers and engineers to make flexible changes to models and drawings in a constraint-free environment, regardless of the authoring source. Solid Edge does this by automatically integrating the engineering model, interrogating the engineering model and presenting the user with possible design functions seamlessly at their fingertips with a tool called Live Rules. It's like having an experienced navigator with you as you drive. Not only that, models don't need to be regenerated. What this means for the designer, an engineer, and you is blazing fast performance. Solid Edge allows you to make design revisions in minutes instead of hours. This means you can deliver sooner, invoice earlier, lower business risk, and have more opportunity to grow revenue at higher margins with happy customers. The second challenge we will look at is reducing customized content. Sales and engineering staff need to optimize the product specification to give the customer what he wants without reinventing the wheel. It's a balancing act that can greatly impact margin. How many times have you been in a situation where you would like to reuse an existing component in a new design, but you cannot quickly find the design data? Where is it? With Solid Edge SP for SharePoint, you can graphically explore existing assemblies and parts, conduct searches to retrieve the design data. You can also clone existing machine designs and then perform simple add and replace operations to meet the new customer's requirements. And those tools for accelerated design we mentioned before, well, those buddies are there for you to use as well. Wouldn't it be nice to reuse existing data regardless of who authored it, and regardless of what system it was authored in? Well, with Solid Edge for synchronous technology, it allows the user to make precise changes to imported model by adding 3D driving dimensions to any geometry. Another unique capability within Solid Edge is the ability to make direct edits to imported geometry by pushing, pulling, and rotating the geometry. We call this capability the steering wheel. The steering wheel will automatically recognize key features, allowing you to make modifications effortlessly. As mentioned earlier, Solid Edge with synchronous technology has a patented capability we call Live Rules. Live Rules finds and applies original design intent. It means lower overall design cost by having the ability to edit imported data and facilitate better reuse. Our third challenge is managing customer requirements. One of the biggest challenges facing industrial machinery manufacturers is the need to manage the customer's expectations. with the detailed build specifications. Salespeople normally focus on closing a contract. I do, with the minimal information needed to give the customer what he wants. After the customer awards the contract, engineering staff will often need more information to clarify the detailed specification. The challenge is ensuring the customer's needs are clear with enough detail for design and manufacture. The company will incur extra engineering time and higher costs if there's a misalignment. This leads to everybody being unhappy. You have lower margins, and the customer has delays in delivery, and the poor sales guy's on the phone trying to answer all kinds of questions. The challenge is how to estimate the cost and lead time accurately. Sales and engineering experience conflict from overpromising and under-delivering. With Solid Edge, you can do this. We'll help you increase margin by minimizing customer-specific engineering. With Solid Edge for SharePoint, equipment manufacturers can implement a step-by-step sales process with less need for input from the engineering team. Since the engineers are not interrupted as much, they can focus on their real task. New staff need less training, as they can now follow a simple and defined sales process. Sales staff can now select preferred configurations based on experience and standards. Now, I have talked about Solid Edge support in three key capabilities of speed of mechanical design, reducing customized content, and managing customer requirements. However, let's visually see how this is done. Ben, take it away.
All right, thanks, Carl. Let's go ahead and take a look at how Solid Edge can help accelerate our machine design process. The assembly we're going to be looking at today is the Dixie Chopper, a riding lawnmower designed by a Solid Edge customer. To make our work easier, we can apply a display configuration to hide parts and expose only the ones we need to see. In this example, we're going to be mounting a small motor to our frame by reusing and importing legacy data to help accelerate our design process. With Solid Edge, we can quickly convert our 2D drawings to usable 3D models with our Create 3D tool. This tool saves time by allowing our engineers to reuse the existing sketches and dimensions to create a new model. The regions that are located on the sketches can be manipulated to add or remove material to create our desired features. To help speed up this creation process and reduce mouse travel to the command ribbon, we can use the radial menu. A radial menu is a fully customizable and it can contain 16 of your favorite or most used commands right at your cursor. As the model is created, the 2D sketch dimensions attach to the model and they become our 3D driving dimensions that we can use to directly edit the model. If we go ahead and inspect our assembly, we can determine the distance between the holes in our frame. We can then use this information to edit the 3D PMI dimension on our model, and with the help of synchronous technology and live rules, maintain that design intent of the other holes in our model. After our model is complete, we can place it into our assembly and assure that it has the correct fit. To do this, we can use our flash fit assembly constraint, which reduces the steps required to position a part using the mate, planar align, or axial align relationships. If we take a look at our model, we notice that the holes don't exactly line up with the existing holes in the frame. But using synchronous technology and with the help of our steering wheel, we can easily change our model to match those background components. The next component that we are going to place in our assembly is the actual motor. This motor is a standard motor that we might have downloaded from an online catalog, for example, in a non-native format, and we are importing it into the Solid Edge part environment. After we import this part, we can save it and then place it directly into our assembly, again using the flash fit command. The model still has a degree of freedom present, but that allows us to move it closer to where we need it to be in the model using our drag component command. So to attach the motor to the frame, we're going to import another model. This one we may have received from a supplier, for example, or it could have been a model that we created in a previous CAD software that we owned. After importing to the part environment and saving the model, we can then bring it into the assembly environment and constrain it to our existing parts. So again, we'll use the flash fit assembly constraint to add our part to the model. We need to be able to attach the motor to this bracket, but currently you'll notice we have no way to do this. That's not an issue though with Solid Edge and synchronous technology. After editing into the part, we can use the background components to get the geometry that we need to make the change to the part extremely fast. Using the attached dimension, we can then change the value to the desired thickness. The three parts that we placed into the assembly were done so at the top level assembly level. But if we needed to, we can transfer those parts to the subassembly that we're working within in this display configuration, and this will help keep our model organized. Inside of Solid Edge, we also have another tool called Create Interpart Relationships, which helps us to maintain the design intent of our models and save time when making any changes. It detects similar features between models and creates a relationship between them so that when we make a change to one part using synchronous technology, the other updates to match that change. Lastly, after we've finished our assembly, it's fast and easy to push that design out to manufacturing. With the help of quick sheets inside of Solid Edge, we can drag our model into the drafting environment and have it automatically balloon the assembly and create a custom parts list for us. At the beginning, we took our 2D drawing into the 3D environment, but we can also take that 3D part back into the 2D drawing and have it automatically create our views and retrieve the dimensions, saving time and money. So as you can see, Solid Edge helps us accelerate our design process with fast revisions and better reuse of our existing data. Carl, back to you.
Thank you very much, Ben. That was excellent. So let's return to the MJC engineering story and see how they achieved accelerated machine design. The results are compelling. Concept drawing in 2 hours versus 2 days. Concept to manufacturing drawings in 1/6 the time compared to their previous system. Completely productive in Solid Edge, their new 3D CAD system, in just 3 weeks. MJC chose Solid Edge as they transitioned into 3D over an upgrade to 2D AutoCAD. After a 5-day training program conducted by their local partner, similar to ourselves, the designers were fully productive within weeks. MJC is just one great example of how Solid Edge can help you design better. Let's take a look at a few more. AMF Bakery Systems is the world's leading manufacturer of high-speed bakery equipment. From mixers and makeup equipment to slicers, baggers, and post-packaging solutions, as well as washing machines for the bottle industry. Much of the equipment AMF designs and builds is customized and under contract to deliver by a certain date, putting product design on the critical path for profitability. Like MJC, AMF chose Solid Edge to solve their challenges with real tangible results. Their design phase has been reduced, With solid edge parametric design capabilities, when solid edge parametric design capabilities is used on their machine design. Their design process has been cut by as much as 50%. Yes, 50%. Solid edge greatly reduced the amount of rework. Assembly time has been reduced by 15 to 20%. For their complex sheet metal assemblies, rework has been almost completely eliminated. Less overtime, more profit. The list goes on and on. AMF is more dominant than ever. And one last success story for today. Industrial Design Associates is a systems integrator and machine builder specializing in programmable logic control system machines. IDA provides the following to a wide range of industries: custom fabricated machinery and control panels, complete electrical, mechanical installation and turnkey integration, custom robotics, motion applications, machine modifications, and enhancements. Their services include engineering, design, construction, and startup support. They are based in Albany, Georgia, USA. IDA faced many of the challenges we've discussed today, such as increasing customer demands for faster, cheaper, better. They needed an intuitive, easy-to-learn, affordable CAD solution that allowed them to design with speed, import its customers' CAD data regardless of the format, and provide product visualization for sales and marketing. Solid Edge answered the call. Time to market decreased by 33%. Rework rate down from 20 to 2%. Customers able to visualize design in 30 seconds. Ability to win business from large, sophisticated companies. Today, we've shown that the best industrial machinery companies have found a way to significantly improve their performance. They've leveraged advanced software to improve their processes from sales to design to manufacture. And here are the results. Design time cut by 50%, physical prototypes replaced by virtual prototypes, capacity for new product development increased by 30%, manufacturing time cut by 20%, manufacturing costs reduced by 20%, significantly fewer errors and part interferences found in manufacturing, delivery of ergonomically designed equipment by modeling the complete machine in 3D and validating that the access for daily operation, cleaning, and maintenance meets the best industry standards. MJC, AMF Bakery Systems, and ICA are a testament to consistently achieving significant ROI from designing your equipment with Solid Edge. Today, you've heard Solid Edge mentioned throughout the session, but we've not yet formally introduced it. Let's wrap up this session with a brief overview of Solid Edge. Solid Edge is a complete 3D design and engineering solution that addresses the 12 key capabilities for industrial machinery industry. Solid Edge, for 3D part and assembly design, using synchronous technology, accelerates equipment design, speeds revisions, and improves the reuse of previous designs. Solid Edge simulation, for digital validation of critical components, reduces the need to create physical prototypes, thus lowering material and testing costs and improves reliability. Solid Edge manufacturing, for a definition of accurate machining, fabrication, and assembly processes, improves overall manufacturing efficiency. Solid Edge design management improves the overall efficiency of equipment design projects, and ensures that accurate product data, specifications, and requirements documents are available to all. And a growing ecosystem. Solid Edge apps extend the capabilities of Solid Edge. They provide a complete ecosystem for product development and manufacturing that meets the needs of today's industrial machinery manufacturing organizations. There's a vast array of applications, from process plant design to tools and utilities. They support rapid, high-quality product development and functionalities related to design and engineering. The Solid Edge apps include the best-of-breed solution providers like Keyshot for photorealistic rendering, Cortona 3D for product authoring, and CamWorks for manufacturing, and many more. Well, don't just take our word for it. Take the next step. Test drive Solid Edge today with our free 45-day online trial. You can try a full-featured version of Solid Edge free with no obligation. Discover how Solid Edge provides the speed and simplicity of direct modeling with the flexibility and control of parametric design, all in one easy-to-use package. And there you go. That's how you can get to try the Solid Edge for 45 days. And or you can get a free 1-hour assessment. We'll work together with you to assess your strengths and weaknesses, compare them to the best in the business, and pinpoint specific ways you can improve. And if you'd like that 1-hour assessment, there's the information how to go about getting it. Now I know when Tracy sends you the follow-up thank you email, this information will be in there as well. So, I've done all this talking. Ben's done the demo. So now let's open up the floor for any questions you have. Tracy?
Thanks, Carl. I'd just like to remind all attendees to type in any questions they may have in the queue located on the right side of their screen. Looks like we have a couple questions here. First one is, you talked about the abilities of importing data into Solid Edge during your demo, but what kind of options are available for exporting data?
That's a good question. I'll answer that one. I won't go deep into technical explanation here, but it's important to note that all CAD software, is written on top of what's called a kernel. The kernel is in a basic definition, is the math behind our CAD software. And Siemens actually owns and develops the Parasolid kernel. And other CAD companies in the industry actually lease this Parasolid kernel from Siemens. And so what does this all mean when we talk about opening files and the question that you asked referring to saving out data for others to use? Well, saving out your native file as a Parasolid file format will allow other software with the Parasolid kernel to actually open up your files with no additional translation. And aside from the Parasolid format, we can also save out our files out to the industry accepted formats such as STEP and IGES, for example. But another option that you and your customers can take advantage of is the free viewers to view the native Solid Edge data. And we have a few different free tools that are available. One of them is simply just a viewer. Another one is a tool set that allows markups and actually the ability to attach and send reference documents as well in what we call a package collaboration file. So regardless of whatever your needs are to share data, we have a number of great tools to share that information and make sure it's shared accurately and securely.
Okay, thanks, Ben. We have another question. What options are available for data management with Solid Edge?
And that's another great question. Anyone who has worked in the industry knows that product data management, or PDM, is a big deal. And for those of you who have worked with CAD data in an unmanaged environment, such as just a directory structure on a shared network, for example, I'm sure that you know that it can be a big pain. but also how dangerous it is, and ensuring that you're using the right files on the right projects at the right revisions, and that someone else is not just messing with your files and messing up your designs. So Siemens provides many solutions for PDM. Some of them are from free PDM-only solutions that are included with Solid Edge to standalone and seamlessly integrated PDM and PLM products that can take your products from pre-concept all the way up through the end of service. So you can be sure that the Siemens products can manage your PDM for you. And the personal experience of myself and our other engineers here at Ally, we fully understand these needs, and we can work with you to assure proper implementation of those. And this is actually a great opportunity to take advantage of Carl's offer for the one-on-one meeting to discuss your particular needs and how we can help you find and implement the proper solution that will help you accelerate your design process, make those faster revisions, and also enable the better reuse of your data.
Okay, great. Thanks, Ben. Doesn't look like we have any more questions at this time, so we're going to conclude the webinar. If you have any more questions, please feel free to reach out to Carl Engler. He'll be more than happy to follow up with you. You can see his contact information on the screen, and I'll include it with the recorded link that you'll get within the next day. Thank you, Carl and Ben, for presenting today, and I'd also like to thank everybody else for joining us.